Let's solve this example 4. And the question is, a soil profile is shown in figure 9.17, and given h1, this is h1, the distance for h1 is 6 feet, and h2 3 feet, and h3 is also 6 feet, and calculate total stress, pool water pressure, and effective stress, and plot the variations with depth. Okay, this is point A, this is point B, this is point C, and this is point D. Okay, let's calculate total stress, pool water pressure, and effective stress at point A. We know total stress is distance into unit weight. At point A there is no distance, so total stress will 0, and at point A, pool water pressure, we know the pool water pressure formula is distance into water unit weight, but this is groundwater level, and we know, I already mentioned, above the groundwater level and in the groundwater level, the pool water pressure is 0. Please memorize this. Above the groundwater level and in the groundwater level, the pool water pressure is 0. So our point A is located in above the groundwater. This is groundwater level or table. So A located in above the groundwater level. So so pool water pressure is 0, and effective stress will also be 0. At point B, at point, this is point B, and we know for point B, total stress, we know total stress formula is distance into unit weight. So this is for point B, the distance is 6 feet, and this is dry sand area. So then this will dry unit weight. Okay, let's calculate dry unit weight. So the formula is for dry unit weight is specific gravity into water unit weight divided by 1 plus void ratio. So the value will dry unit weight is 110.24 pound per feet cube. Okay, let's use this value for point B, 110.24 into 6. This value is 110.24, and the value will total stress for point B 661.44, and calculate pool water pressure at point B. B is also located, B point is also located above the groundwater level. So pool water pressure at point B will also 0, but there has a condition. This is zone of capillary rise, water will rise. So this is zone of capillary rise, and for this condition there is another pool water pressure which is UB prime, and for capillary rise we know the formula is minus saturation into water unit weight into H2. Here saturation is 50%, so zero point 0.5, and we know water unit weight, this is fixed value for feet unit, this is 62.4, and H2 is 3 feet. Okay, the value will minus 93.6 pound per feet square. This is for capillary rise, and 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 calculate the effective stress. We know effective stress is total stress minus pore water pressure. Here total stress is 661.44 and pore water pressure is 0. So effective stress at point B will 661.44 pound per feet square, and for capillary rise, sigma B prime effective stress will 661.44 minus pore water pressure. Okay, this value will 755.04 pound per feet square. This is immediately value point. Okay, let's calculate 4 point 4 point C 4 point C, and this is groundwater level. Okay, 4 point C, we know the total distance is, this is 6 and this is 3 feet. For 6 feet we will use dry unit weight, but for this 3 feet we can't use dry unit weight because there has saturation value is 50%, so this zone is moist unit weight. Okay, let's calculate the moist unit weight. Okay, the moist unit weight formula is specific gravity plus saturation into point ratio into water unit weight divided by 1 plus buoyant ratio. So the formula, this is the formula, and the value will 120.64 pound per feet cube. Okay, so for point C, the total distance is 6 plus 3. For distance 6 we use dry unit weight, and for distance 3 we use moist unit weight. Okay, 6 into dry unit weight, 3 into moist unit weight. So total stress at point C will 1023.36 pound per feet square. Okay, let's calculate pore water pressure at point C. This is point C and groundwater table is located here. As I already discussed that at point at groundwater level, in groundwater level and above the groundwater level, the pore water pressure is 0. So the pore water pressure is 0, and calculate effective stress. Effective stress is total stress, which is 1023.36 minus pore water pressure, which is 0. Then effective stress will 1023.36 pound per feet square. Okay, at point D, at point the total distance is is 6 feet, and this is 3 feet, and this is also 6 feet. Okay, we already calculate that 6 into, we already calculate 6 into dry unit weight. This is for dry unit weight, and this distance is 3. This is for moist unit weight. 3 into moist unit weight. Then our value was 1023.36. Okay, let's insert 1023.36, and we have this is 6 feet, and this is saturated glass zone. So unit weight, we saturated unit weight. So saturated clay will, the formula of saturated unit weight is water unit weight into specific gravity plus void ratio divided by 1 plus void ratio. Here specific gravity is 2.71, and water unit weight is 42%. Okay, so this is another formula for finding void ratio. Let's insert all these values. We get saturated unit weight for clay, which is 112.3 pound per feet cube. Okay, okay. Then the distance was 6 feet, so 6 into 112.3. Okay, then we get, for point D, total stress is 1697.17 pound per feet square, and the formula of pool water pressure is distance into water unit weight. Okay, here this is, this is groundwater level, and for point D, the distance from groundwater level to D is 6 feet. So the distance is 6, and water unit weight is 62.4. This is fixed value for feet. Then we get 374.4 pound per feet square. Okay, then at point D, the effective stress will total stress minus pore water pressure at point D. Then the value will 1322.77 pound per feet square. This question is plot the variations with depth. So I just plot the variations with depth. This is point A, B, C, and D. For point A, we have total stress is 0, pool water pressure will also 0, and this is 0, and effective stress is 0. And at point B, the total stress is 661.44. We get these values from, and pore water pressure is 0. So at point B, total stress is 661.44, and pore water pressure is 0. And for capillary rise, the pore water pressure is negative 93.6, and effective stress is 755.04. This is for capillary rise. And 661.44, this is effective stress. Okay, I just draw a line. This is pool water pressure 0, so this is also 0, and this is minus 93.6, and this is 755.04, and at point C the total stress is here, and at point C pool water pressure also 0, and effective stress is 1023.36. Okay, I just adjust the line through the point. Okay, thanks for watching my video.